Hello, here's your geometry video for section 7.4, Applying Properties of Similar Triangles. Missy McCarthy, Okemos High School math instructor. In this lesson, you'll learn to use the properties of similar triangles to find segment lengths and to apply proportionality and triangle angle bisector theorems. The triangle proportionality theorem is listed here, and that theorem states that if a line is parallel to the side of a triangle and intersects the other two sides, then it divides those sides proportionally. In that, if we have our triangle ABC and line EF is parallel to the BC side of the triangle, then it divides the triangle in such a way that AE is to EB, just as AF is to FC. Now that's very different from our usual proportionality in a triangle. Let's say we had a triangle like this, and then we had another that was overlapping it like this. And say for whatever reason, and that should be directly on top, we could prove that these two triangles were, let's say this angle was congruent to this angle, and then these angles are congruent to each other, obviously. And so the two triangles were congruent by angle, angle. If we call this A, B, C, D, and E, what we are used to saying is AD is to AB, this whole side, just as AE is to AC, this whole side. Now that still holds true because these two triangles are similar by angle, angle. But this is saying not necessarily that we have two triangles, but we have a line that's parallel to the third side. Then AE goes with EB, just as AF goes to FC. It's called the triangle proportionality theorem. So here's a problem we can try. We're commissioned to find the value of US. So if we look here, we see that VU is parallel to ST. So using the triangle proportionality theorem, we can say that RV is to VT, just as RU is to US. And the only value that we do not know is US. RV is 10, VT is 4, RU is 14, and US is the value we don't know. So when we cross multiply or find the cross product, we end up with 10 times our segment US is equal to 4 times 14. So that's 10 US is equal to 56. And then divide both sides by 10. And we get the value of US is 5.6 units. Now, the converse of the triangle proportionality theorem also works. If in a triangle that AE is to EB, just as AF is to FC, if that is true, then it's safe to draw the conclusion that this segment EF is parallel to BC. So this is the converse of the triangle proportionality theorem. So we can verify that they're parallel simply by showing, let's do that. Simply by show that AE is to EC, just as AD is to DB. So if we say 8 is to 12, just as 10 is to 15, and we find the cross products, 8 times 15 equals 12 times 10. That gives me 0, 4, 8, add 120, and 120. So yes, because these are the same, we can say that segment DE is parallel to segment BC. And that's by using the converse of the triangle proportionality theorem. And boom. All right, another theorem, or maybe shall I say a corollary, a result of having the triangle proportionality theorem, is something called the two transversal proportionality. So if you have two lines, line AC here and line BD here, and then you have three lines that look like they are parallel, or it does say that they are parallel, three or more parallel lines. So actually I want to write that on here, but that is parallel to that, which is parallel to that. If three or more parallel lines intersect two transversals, then they divide the transversals proportionally. So AC, this segment here, is to CE, this segment here, just as BD is to DF. And it's really the triangle proportionality theorem if we were to extend it somehow and make a triangle. It's very connected to that. So it's a result of the triangle proportionality theorem. Now, the only other theorem that we're going to concern ourselves with regarding triangle proportionality is the triangle angle bisector theorem. So if you have your initial triangle, A, B, C, so that's your initial triangle, and you have an angle bisector, AD, that divides these two into congruent angles, okay? And also it would intersect the opposite side at point D here. Then we have proportionality in this triangle such that BD is to DC, just as AB is to AC. Okay, again, that's BD goes with DC, just as AB goes with AC. Okay, so let's use, and this is not the proof of the triangle proportionality theorem. I was going to do the proof of the triangle angle bisector theorem, but decided against it. So this is actually just an example of using the triangle angle bisector theorem. So for this example, we know that QS is the angle bisector because of those. So we can set up a proportion. We can say RS is to SP. So RS goes to SP. Now we have to come back over here, just as QR is to QP. So RS is x plus 5. SP is x minus 2, QR is 40, and QS is 32. So we get 32 times x plus 5 equals 40 times x minus 2 when we do our cross product. Then we get 32x plus 0, 1. What would that be? Oh, why am I doing this? 32 times 5. 0, carry the 1, 15, 16, 160. And then 40x minus 80. Get that off there so we'll have room to write. Okay, so then if we come up here and we subtract the 32x from both sides and add the 80 to both sides, we got 160 plus 80, which gives us 240, I believe, equals 8x. And then divide both sides by 8. And we get x is equal to 30. So we're trying to find PS and SR. So PS, which would be 30 minus 2, so PS would be 28, and SR would be 30 plus 5, so SR would be 35. Okay, rewatch any parts of the video for full understanding of applying those properties. If you have questions, please post them in the comment section, and there is a lesson quiz right here at the end.